space, so there's no friction. And then we've also learned that there is no sound. So to get sound in space, there should be molecules so that there'll be sound. And we've also learned that there's light only in space, so there are electromagnetic waves. And we'll also learn about other planets that are in space, about the universe, and that there are billions of galaxies.
And first we look at our goal, and our goal is to take the nice picture of planet Earth. So then we consider vessels like a rocket. Then we find that a rocket is too expensive and it would be difficult for us to get a rocket. So then we left a rocket. So then secondly we considered a ladder. So then, and the ladder is too short for us. So thirdly we looked at a sling. So a sling will require a lot of force, a lot of energy. So we cannot do that. So then we thought of a balloon. So then a balloon it's light, so and it's not expensive. It would be easy for us to get a balloon. So the balloon will put a helium gas inside because it's the lightest gas that I know. So I think it will be fine. So it will make the balloon to go high. We'll also take a camera with the balloon, so to take the picture of Earth and some other stuffs, to do some experiments.
What I want to talk about is what we want to send into space. I think firstly we want to send an elastic rope, an elastic rubber band to explore if there'll be any change in the band after it came back from space, or whether it will still remain elastic as it is, or maybe it will lose shape or something. And also a tennis ball, a softball like a tennis, to check whether it will also change shape, or maybe it will enlarge, or it will be like 5 times smaller as it is. So we wanna explore the change in it. And also we wanna send a plant. Like we wanna take 2 plants, and one of them will send it to space, and one of them will remain back on Earth, to see what will be the difference in these 2 plants. If in the difference in the plants, like the one we sent in space and the one that remained on Earth. So yeah, I think that's most of the things we wanna send, actually, just to compare the difference in them.
So I'm going to talk about the launching site and the landing site of the balloon. So on the launching site, we looked at our options where we can either launch the balloon at a lower altitude, but then we saw that the disadvantage is that the balloon it will take a long time for it to reach where the space. But then if you launch it in a high altitude, it will be like it will take a less time for it to reach space. And the landing site, so when we launch the balloon, we look at the wind, the direction of the wind. So when the wind is going north, we'll go southwards, and then we launch the balloon from there, so that the wind can blow it northwards to where we want it to be. That's important because we want the balloon to land in a place where we can find it, because if we just launch it, it can land in Mozambique, and it can land in places where it's unreachable, where you can't find it. And it also needs to land in a place where there's not a lot of trees, so that it can land like where we can be able to reach it or see it. It can also land in Kruger, and we don't want it to land in any of those spaces because it would be hard for us to get it. Yeah, it can be eaten by animals.
I wanted to ask more about the normal daily communication language, like the type of language they use each and every day. Because I've heard I know they are using English, but there are some sort of type of English. Maybe I'll be interested to know what type of language are they using, and how do they use it in their daily usage, because I know that they're not using formal English every day. So, yeah.
I'd like to know what they do for fun. Besides doing the space balloon and stuff, or doing schoolwork, what do they do for fun in general?
I would like to know if about their culture. Yeah, what do they do? What do they celebrate? Do they have any ceremonies in South Africa? Yeah.
I want to know about the music industry there. I want to know if music, is it a subject, or maybe it's compulsory for everyone. How do you do it? I'm the sun. So when I'm shrinked 10 billion times, I'll be of this size.
Good.
And I'm the earth when I'm like, I represent earth, and when I'm shrinked in like 10 billion times, I'll be this size. Yeah.
This is Jupiter when it is reduced, and it's 77 meters away from the sun.
And I'm Venus, and when I'm shrinked 10 billion times, I'll be this side 10 meters away apart from the Earth.
And I will be Mars, the smallest, or at least from the planets we have. It's just a grain of sand, or a big grain of sand actually, but very small. Shrunk 10 billion times.
So from the sun, I'll be 10 meters. So I'll go like 1, 2, 3, 4, 5, 6, 7.
Okay, Earth.
I contain life. And then I'm Earth. My distance from the sun is 15 meters when it's reduced 10 billion times. So I'll be this size away.
Okay, I'm Mars. I'll be 22 meters from the sun.
So I'm Jupiter, and I'm the furthest with 77 meters from the sun.
We are Imagine scholars who are going to beat you into space.
Unity first, and the rest will follow. It's hard to unite, but it's easy when you believe. Love is to care for yourself and for others. Start from within. Watch us as we put unity first.
Take pride in the vision. Unity first. Make things happen.
Unity first, and the rest will follow. It's hard to unite, but it's easy when you believe. Love is to care for yourself and for others. Start from within. Watch us as we put unity first. For all of us. For love and no share, trust the fact, no matter religion. 'Cause we are all one. Yes, we are all one. Unity first, and the rest will follow. It's hard to unite, but it's easy when you believe. Love is to care for yourself and for others. Start from within. Watch us as we put unity first. It's happening when we're united, and peace is there within. Where the smile and progress and change. It's happening when we're united, and peace is there within. Where the smile and progress and change.
Am I that invisible?
Yes, you're invisible, Roger.
Okay.
The distance Sun-Earth is 149 million kilometers. Watch out for the snake.
Oh, there's no snake inside.
Oh, okay. The distance between Sun and Venus is 108 million kilometers.
Can I open this one?
Yeah.
Jupiter is 778 million kilometers.
I can't read Chinese. It's written in Chinese.
Uranus, 2,877. Yeah.
This one.
Show what's inside. Is it open or not?
No, it's not open.
Oh.
Whoa.
It's heavy.
Heavy. Wow. Wow. Yeah, that's really heavy. Not more than like a birthday balloon.
And then we can show them. If you would shrink the solar system 10 billion times, we can show in meters how far the planets are apart from the sun and from each other.
What is for like to track the signals?
Who's going to be Venus?
I want to be the smallest planet.
Actually, that should be Wendy because Venus is a sign of female. Female sign.
Yeah, I know, really.
It is you give a small signal on the input and then it switches. It's like a switch. It's
Yeah,
an automatic
it's
switch. Without you don't do it manually, but you can do it by a computer. Who will be Earth, of course. Earth. Roger, yes.
I contain life.
A GPS module. So that's how we can track the balloon, or the balloon knows where it is. Actually, we can't track it yet, but the balloon knows where it is. Then we have the radio module. We have a sending module in the radio, and we have a receiving module. We keep the receiving on Earth, of course.
Yeah.
Put the transmitting one in the balloon, and then the coordinates. It will send it to Earth, to us, and then we'll be able to track it. So that's and the balloon, of course, and the parachutes are some important components we are lucky to get from Gavin. And I have to say that the radio is from Radiometrics, and they sponsored us. I asked if we can get some help from them in this project. So I would like to thank Radiometrics. Maybe you can say also thank you, Radiometrics.
Thanks, Radiometrics.